Good morning, students. I would invite Arun sir to start the session.
Thank you, ma'am. Right. Good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning. All right. So let us continue with problems, and we'll go to wedge constraints today. Right. Uh, I told you we have got Fourier constraints, string constraints, Fourier string constraints, wedge constraints, and general constraints. So we'll continue with Fourier constraints, couple of problems, and then we'll go ahead with wedge constraints. Right. I have a problem here. What is he asking? The ratio speed of the block. All right. So in all these cases, the upper block on the table, horizontal table, is being pulled towards left with velocity v naught. All right. So determine the velocities of the hanging blocks. Tell me the velocity of this block: 1, 2, and 3. Tell me 2 first.
Sir, it is V0.
For which one? This one. 1.
No, sir, for 2.
For 2, it's v naught. Upward or downward?
Upward, sir.
Upwards. Upward v
Downwards.
naught.
Yes, sir, upward.
Huh. Right. Now look at this one or this one. Look at this one. This is easier.
So, V0
V0 only,
by
sir.
2.
It cannot be v naught. See, there's a difference between these
Sir,
two. So there has to be
V0
a
by
difference.
2. V0 by 2, sir.
Okay. How about this one then?
Upwards.
How about this one?
Sir, is it V0 by 2?
For 1
Yes,
or 3?
sir, V0 by
3, sir.
For
3,
3,
3.
sir.
For 3, v
3.
naught by 2 is right. All right. For 1,
2 V0.
Yes, sir, 2 V0.
right. It's 2 v naught upward. And this is v naught by 2 upward. Is it clear for everyone?
Yes, sir.
All I'll do is either I can use that pulley ka equation. Velocity of this is 0. Velocity of this is Vx. V naught is equal to Vx plus v naught by 2. So Vx is equal to v naught. Over here, velocity of this point is 0. Velocity of this point is v naught. Velocity of the pulley is Vx. So Vx is equal to v naught plus 0 by 2, which is v naught by 2. Either I can use it this way or push-pull method, because one end of the string is fixed. One end of the string is fixed, so I can use push-pull method. Right? If I push this pulley down by x, string slackens by 2x. This block comes down by 2x. So if this goes towards right by x, this comes down by 2x. V naught to v naught. If this goes towards left, this goes up. Similarly here also, if this goes up by x, string slackens by 2x. So this block goes by 2x. So if this is V naught, this is 2 V naught. Or if this is V naught, this is V naught by 2. All right. Okay. Now I'll send a question. I'll put a question now. Another question. The numbers are A acceleration is 12t. Its acceleration is 3 meters per second square. All right. They start from rest. All right. A and C start from rest. So obviously B also starts from rest. If this is the acceleration of the particle A and this is the acceleration of the particle B, what is the acceleration of the particle C? B, sorry. A and C is given. I have to find the acceleration of particle B. How do I do? None of the end of the strings is fixed. None of the ends is fixed. So I cannot use that push-pull method. I'll go for pulley equation.
Yes, sir.
So what is the acceleration of this one? So acceleration of this point is 12t downwards. Acceleration of this
Sir,
point is 3 upwards.
15.
So acceleration of this point will be this plus this by 2. Let us say top part I take as positive. 3 minus 12t by 2 is my acceleration of block B. Right? So it will be 3 by 2 minus 60.
Yes, sir.
All right. Now, tell me one thing. After what time will the acceleration of the block B become 0?
Sir,
After what time will the acceleration of the block B become 0? Plot this equation. How do we get? What do we get? 3 by 2. Initially, t equal to 0. It's going like this. Right? This is A versus T graph. A versus T graph, what are the information I can get? Area under the graph. Area under the graph will give me change in velocity. It started with 0 velocity at t equal to 0. It is accelerating. At some time t, it is accelerating. Acceleration is positive, decreasing but positive, decreasing but positive, decreasing but positive. That means particle is going on speeding up. So it will speed up till this time, till acceleration becomes 0. After that, acceleration reverses and then it starts retarding. So when this area equals this area, my particle will again come to rest. Do you all agree?
Sir, can you explain once again?
Yeah, I'm just understanding the situation. What is happening? What could be the possible questions? I've got this scenario where acceleration of A is like this, B is like this, and C is like this, and B is deduced to be like this. Acceleration of B is not given in the question. He is asking acceleration of B, which is given as 3 by 2 minus 60. Now, the question is, after what time will the particle reach maximum velocity? If I plot the graph, I get AT graph. Area under the AT graph gives me velocity, change in velocity. If it starts from rest, I'll get the velocity of the particle after a time t by finding out the area under the graph. If I analyze this graph, what can I say about the particle? What's happening to the particle? At any time t, it started from rest, it's accelerating, so it's speeding up. After some time, delta t, its acceleration reduced, but it's still positive. Acceleration is reduced, but still positive. That means it's still speeding up. It will go on speeding up till the acceleration becomes zero. Once the acceleration reverses, the particle start retarding. Then it can again come to rest when these two areas are equal. When these two areas are equal, particle will again come to rest at t naught, let's say, such that this area is equal to this area. If you tell me this value, what is this value? From this equation, can you tell me this value? I've given you the equation. I'm just asking you this x-axis intercept, x-intercept. I've given you the equation. 3 by 2 minus 60. How do you get the x-intercept? Students,
So 2/3 time.
minus 2 by 3. How? I equate it to 0, no? So 3
Yes,
by
sir.
2 is equal to 60. 3 ones, 3 twos. So t is equal to 1 by 4. 1 by 4, no? Is it correct? Is my calculation correct? Is it correct?
Yes, sir.
Yes, sir.
So if this is 1 by 4, what is this time then? What is this time when the particle stops? That means when the areas are equal, what is this time? It's a look and see. You can look at the triangle and tell me. This area has to be equal to this area.
The 7 by 4.
So 1/2. So 1/2.
Haan,
1 by
1 by
2.
2, because this is 1 by 4, it will double of that. 1 by 2. So after half second, particle will again come to rest. All right. You all agree with that? At what
Yes,
time is
sir.
the particle B achieves maximum velocity? At what time is the B achieving maximum velocity from the graph?
So
4. 1 by 4.
1/4.
Yeah, 1 by 4. Yeah, don't think much about it. See, ఇక్కడ వరకు యాక్సిలేట్ అవుతూనే ఉంది. యాక్సిలేషన్ పాజిటివ్ ఉంది. యాక్సిలేషన్ తగ్గింది కానీ పాజిటివే ఉంది. So it's going on accelerating, speeding up, speeding up, speeding up. Till when? Till acceleration becomes zero. Because after that, acceleration is becoming negative. Velocity is positive, but acceleration is becoming negative. So particle starts retarding after 1 by 4. So till 1 by 4, it's speeding up. So maximum velocity ఎప్పుడు ఉంటుంది? 1 by 4 దగ్గర ఉంటుంది. Alright. Or my area is going on increasing. Area decreases only after I cross 1 by 4. So till 1 by 4, my area is going on increasing. So delta V is going on increasing. So final velocity is going on increasing. It's going on speeding up. So 1 by 4 is a point where at time at which particle reaches maximum velocity. All right. Okay, now let's go for next one. This is A, B, C, and D. Sorry, the question says A is going up with 1 B is going up with 7 and C is going up with 2. 1 meter per second, 7 meters per second, 2 meters per second. Required to find the velocity of D. A, B, C, D in given configuration. A is going up with 1 meter per second. B is going with 7 meters per second. 2 is going with 2 meters. C is going with 2 meters per second upward. All are going upward. I have to find the velocity of D. And these upwards are with respect to ground. If not mentioned, they're all always with respect to ground.
Sir, 6, sir.
Upward or downward?
Sir, upward.
I'll give you the options. 7 upwards, sorry, 7 downwards, 2 downwards, 10 downwards, 8 downwards. All any options are downwards only.
10, sir.
Sir,
How do we do this problem?
6
How do we do this
downwards,
problem?
sir.
Huh?
6 downwards, sir. 6
Formula.
downwards.
6 downwards, huh? How do we do this problem? How do we do this problem? See, I know velocity of this end, which is 2 upwards. Velocity of this end is required, Vx. Velocity of the pulley is required. This is ultimately required, Vx, for which this is needed. Velocity of the pulley is needed. But velocity of the pulley is same as this pulley. If this pulley is going up, this pulley is coming down. And this is going up with what velocity? 7 plus 1 by 2.
4.
4. So this is coming down with 4.
Yes, sir.
So if I take upward as positive, 2 plus
Fine.
Vx by 2. నాకు Vx is తెలీదు పైకి వస్తుందా కిందకి వస్తుందో తెలియదు నాకు. I'll
Sir,
just say Vx.
minus.
I don't know Vx is upward or downward. Alright. I'll just take it as upward. Presume upward. Post negative వస్తే reverse. 2 plus Vx by 2 is equal to minus 4. So Vx is equal to minus 10. Minus 10 అంటే 10 meters per second downwards.
Yes, sir.
Alright. So where have you gone wrong?
Sir, Vx నేను డౌన్వర్డ్ అనుకున్నా సార్.
Okay. సరే downward అనుకుందాము.
మైనస్
So Vx 2 minus Vx by 2 is equal to
4 పాజిటివ్ తీసుకున్నా సార్. 4
okay, okay.
పాజిటివ్.
ఓకే ఓకే అది నెగటివ్ కదా కింద ఉంది కదా నెగటివ్ తీసుకోవాలి దట్స్ ఓకే ఓకే నౌ లెట్స్ మూవ్ ఆన్ టు look at this students I'll draw a diagram and you tell me what is happening. You understand the diagram? This is a bigger block, huge block, smaller block. Bigger block ki pulley ila attached undi. This string is attached over to the wall. One end of the string is fixed. The other end is attached to the block, hanging vertically. Now, if this block moves towards left with velocity v naught, I have to find the velocity of this block. So ఎలా ఆలోచించాము? So this I haven't told you how to do. I'm not asking you how to do. What should we do? ఎలా ఆలోచిస్తాము? Look at this. I move this hypothetically, I move this block by x.
Sir, is it
String.
2V0?
అంటే మోషన్ ఎలా ఉంది ముందు చెప్పగలుగుతారా?
Sir,
Downwards ఉంటుంది సార్.
downwards, sir.
కానీ ఇది లెఫ్ట్ కి వెళ్తుంది, అది డౌన్వర్డ్ వస్తుంది, అంటే అల్టిమేట్లీ బ్లాక్ ఇలా వస్తుంది కదా, ఒక డయాగ్నల్ లో వస్తుంది కదా.
Yes, sir.
సో యూ షుడ్
Sir.
ఐదర్ టెల్ మీ డైరెక్షన్ అండ్ మాగ్నిట్యూడ్ ఆర్ ఐ క్యాప్ జే క్యాప్ లో చెప్పాలి. ఎందుకు డయాగ్నల్ వచ్చింది? ఇట్స్ కమింగ్ వర్టికలీ డౌన్ విత్ రెస్పెక్ట్ టు దిస్ బ్లాక్ అండ్ దిస్ బ్లాక్ ఇస్ కమింగ్ టువర్డ్స్ లెఫ్ట్.
Yes, sir.
So let us see what is happening. If this block comes towards left by x, string slackens by x. This string is to be tightened by moment of this block downward by x. Right? So in block మీద నుంచుంటే, if this block moves with v naught, this block, small block, comes down with v naught with respect to the block, bigger block. Is it correct?
Yes, sir.
Sir, can you repeat it?
If this bigger block, I'll draw the block better in a better way. Okay. Now this block is coming towards left with by x, let's say. X left కి వచ్చింది. So string will slacken by x. This slackened string, this pulley will now come to this point. So this slackened string will come down like this, and this block will come down by x. You all agree?
Yes, sir.
Yes,
భావన
sir.
అర్థమైందా?
Yes, sir.
This block is moved towards left by x. I'll take a snapshot. ఈ స్ట్రింగ్ ఇలానే స్లాక్ అయిపోయింది, x స్లాక్ అయిపోయింది. ఆ స్ట్రింగ్ టైట్ కావడానికి this block has to come down by how much amount? X amount. So this is coming down
Yes,
by
sir.
x. Right? Okay. That means if I stand on the block, ఇది x తో కిందకు వస్తుందంటే, if this is going with velocity v naught, this is coming down with velocity v naught. With respect to the
Yes,
block, with
sir.
respect to the bigger block. But bigger block itself is moving towards left with v naught. And this is always in touch with this, contact with this. So velocity, x component velocity ఎలా ఉంది? Minus v naught I cap. J component velocity ఎలా ఉంది? Minus v naught j cap. So this is my ultimate velocity of the block vx. Or I can say v naught is this way, v naught is this way, resultant is v naught root 2 at an angle of 45 degrees with a horizontal. This one or this one, it's same, no? Say information is same, right? These two give you the same information. This is in vector form, component form. Both are in vector form. This is in component form and this is in geometrical form. So block is going diagonally this way with a velocity of v naught root 2. Is it okay?
Yes, sir.
Okay. Now, same thing, let us say it's going towards right. The block is going towards right with velocity v naught. ఇప్పుడు ఏమవుతుంది? What will happen to the smaller block? Will it go upward or downward?
Upwards.
Sir, upwards and small.
Upwards. Right. ఎంత అమౌంట్ వెళ్తుంది? If this goes up by x, goes towards right by x, it will go up by x.
Yes,
So
sir.
its velocity will be v naught I cap, that is towards horizontal, is along with the block, bigger block. Vertical velocity is plus v naught j cap. So my velocity of the smaller block is V naught I cap plus V naught J cap, or its horizontal velocity is V naught, vertical velocity is V naught, resultant velocity is V naught root 2 at an angle of 45 degrees.
45 degrees.
All right, ఇలా అయినా చెప్పొచ్చు, అలా అయినా చెప్పొచ్చు. Mostly it will ask you options will be like this or like this. They could be like anything, but the information is same. All right, now
Yes, sir.
let us do it this way. I'm making small changes in this one. Now this block is going towards left with V naught. V naught. ఇప్పుడు ఏమవుతుంది?
ఇప్పుడు డౌన్వర్డ్స్ వెళ్తుంది సార్ బ్లాక్.
బ్లాక్ డౌన్వర్డ్స్ వెళ్తుంది, రైట్? ఎంత వెళ్తుంది? Now there is a string attached here also. If I move this by x towards left, the string is slackened by x ikkada, x ikkada.
Yes, sir.
So it is
2x.
slackened by 2x. This has to come down by 2x.
2x.
So if this is moving velocity v naught, its vertical velocity will be 2v naught. So 2v naught minus 2v naught j cap. Horizontal velocity ఎలా ఉంటుంది? Same as that of bigger block because both are in contact.
Minus V naught.
So minus v naught minus 2v naught. అదే ఈ వెక్టర్ ఫామ్ లో చూపిస్తే how will it be? It will be resultant of these two. 2v naught downward and v naught leftward. So resultant will be somewhere here at an angle of tan inverse 1 by 2 with the vertical, and resultant will be v naught root 5.
Yes, sir.
Okay. Is it clear?
Sir,
Yes, sir.
angle ఎంత ఉంటుంది, sir? Angle.
Angle ఎలా వస్తుందా?
Yes, sir.
See, it is like this. ఇది v naught. Leftward velocity is v naught. Downward velocity is 2v naught. Resultant will be like this. Diagonal. ఇది v naught. ఇది 2v naught. So this angle is theta అనుకుంటే tan theta is v naught by 2v naught. So tan inverse of 1 by 2. v naught by 2v naught is tan theta.
Yes,
So with the
sir.
vertical it is tan inverse 1 by 2. With the horizontal it is tan inverse 2. 2v naught by v naught. Tan inverse 2 ఇది, tan inverse 1 by 2 ఇది. Alright?
Yes, sir.
Okay. Did you do the homework? Did you try? Did you get any time today, yesterday after class? 10 minutes could you spend?
Yes, sir. Yes, sir.
Good, 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 good. Good, Bhavna. Others? See, the more you practice right after the class, just before you sleep, the better it is. Right? So, Bhavna, what have you done? Like, have you applied the same pulley method to the push-pull method problems?
So both methods.
Both methods to solve చేసావా? Very
Yes,
good.
sir.
Very good. Any doubt you have got in any problem?
No, sir.
Okay. Same answers వచ్చాయా?
Yes, sir. Same వచ్చింది.
Same వచ్చాయా? All right. Good. There are three blocks, A, B, and C. If A is going with velocity V naught, find the velocity of B and C. ఎలా చేస్తాను? I know that B and C velocities are equal. Why? Because if this moves by x, this also has to move by x. ఒకటే స్ట్రింగ్ తో అటాచ్ ఉన్నాయి, రైట్? సింగిల్ స్ట్రింగ్ అటాచ్ చేసి ఉంది. So if
Sir,
this comes
2
down by
V
x, that was quick. Good. Others? Navneet, Hashini, Divya, Ashrita, Vignesh. Hmm? Yeah, what do we do? How do we do? This is one end of the thing is fixed. So I can use a push method. Or pulley method is, if you are comfortable in any one method, that's enough. But push method is faster. It push cheste by x, string size by 2x. This 2x has to go towards right. This block V has to go towards right by 2x. So V naught, 2 V naught, 2 V naught, 2 V naught. So V naught, 2 V naught, and 2 V naught are the velocities. Fine, that's comfortable. But if I use pulley equation, if this is V naught, velocity of this point is 0, velocity of this point is VB. Right? Velocity of the block is same as this point. And velocity of this block is VB itself. So velocity of this point is VB towards right. This is 0. So VB plus 0 by 2 is equal to V naught. So VB is equal to 2 V naught. If VB is equal to V naught, VC is also equal to 2 V naught. Right? That's what we do. Pretty simple, right? Now let's complicate this a bit. Instead of having this as C to be this way, this is my C. Now tell what the velocities are of VB and VC. You can use pulley equation or push-pull.
Sir, 4 V naught.
Then VB the
No, sir. C V, sir.
C the 4 V naught. Okay, VB the
V B the sir.
2 V naught. 2 V
2
naught.
V naught.
V naught.
yes, Divya, you're right. 2 V naught. 2 V naught and 4 V naught. ఇక్కడ వరకు సేమ్ సిచ్యువేషన్ ఉంది, ఓన్లీ ఇక్కడ నుంచి మారింది. ఇక్కడ నుంచి 2 V naught వచ్చింది మనకి. If this is 2 V naught, this pulley is going down with 2 V naught. This is at 0. This is VC. VC plus 0. I don't know where direction of VC. VC plus 0 by 2 is equal to 2 V naught. So VC is equal to 4 V naught. I've taken downward as positive, so I got positive. It's going downward with 4 V naught. Or if this moves down by x, this moves down by 2x. So if pulley moves down by 2v, block has to move down by 4v. Okay, that's faster. V naught, x, 2x, 2v naught. 2v naught, x, 2x, double of this one, so 4v naught. Okay. Now I'll make slight change in this one. I'm just making you do more and more practice, all right? Because you're not getting enough time to do after the class. I'm making you do in class itself, all right? All you have to do is do all these exercise again. మళ్ళీ చేయడానికి అంత టైం పడదు. All right, so that is the homework you have got.
Sir, is it V naught by 2?
velocity of B ఎంత?
2 V naught only, sir.
2 V
Sir,
naught.
V
ఇది
naught, sir.
V naught. See, ఇది 2 V naught. ఇది కింద వస్తుంది 2 V naught తో. ఇది 0 ఉంది. ఇది VC ఉంది, VX కావాలి. సో V naught,
Yeah, sir.
2 V naught plus 0 by 2 is VX. So VX is equal to V naught.
Yeah, sir. And 2 V naught రాసుకోకుండా V naught రాసుకున్నా just.
That's what. Be careful. In the exam కూడా అలాంటి మిస్టేక్స్ అవ్వచ్చు. Okay, now there is one diagram which is difficult to draw. So I'll send the pic of the diagram. Have you received?
Yes, sir.
First pic is a question. Second pic is a diagram. See, in these losing and tightening questions, what am I doing? ఎంత లూజ్ అవుతుంది అంతే టైట్ అవ్వాలి అంటున్నాను. Right? Okay, anyways, that will talk after this question. So we have got a question, crazy diagram. What is the speeds he has given? 60 and 120. Or V naught to V naught. Centimeters per second. All right. Required to find velocity of this load. Vx. Think about it. Use that pulley method. We cannot use push-pull method. right? Because none of the ends is fixed, or the string is fixed. Use that pulley equation. VA plus VB by 2 is equal to VP.
So is it 30?
30, you got 30?
No, sir, 90.
90? Okay. No, let's talk about the approach. What are you doing basically? I'll mark the points here for your convenience. A, B, C, and D. All right. So what do we do? Required is Vx. What is the velocity of point A? V
60,
naught to V
sir.
naught. Yeah, 60 or V naught. V naught and Rastan. 60 or V naught. I've given it to name to be V naught. Velocity of point D.
2 V naught.
2 V naught. Now velocity of point B C की relation ఏంటి? If point C comes down, point B has to go up. Or if point C goes up, point B has to come down. See, they are connected with the same string. ఈ స్ట్రింగ్ ఈ పాయింట్ కిందకు వస్తే ఈ పాయింట్ పైకి వెళ్ళాలి, ఈ పాయింట్ కిందకు వస్తే ఈ పాయింట్ పైకి వెళ్ళాలి, because they are connected with the same string, right? So let us say it is coming down with velocity v. So this goes up with velocity v.
Yes, sir.
See, whenever you have such pulley problems, spot the points beside on the either side of the pulleys and velocity of the pulley. Write pulley equations, you'll get number of equations equal number of unknowns. ఇక్కడ ఎన్ని unknowns ఉన్నాయి? v ఒకటి unknown, vx ఒకటి unknown. Let's write pulley equation for this one. What do you get? Upward as positive 2v naught minus v by 2 is equal to vx is equation 1. ఆ పుల్లికి ఈ పుల్లికి ఎలా రాస్తాను? v naught plus v by 2 is equal to vx. All right. This is equation 2. Two equations, two unknowns. If at all he asks this point velocity also, you can solve this equation, but he's not asking that point. So eliminate that v. How do I eliminate? I'll add these two equations. Add చేస్తే v by 2 cancel అయిపోతుంది. ఈ 2 ఇక్కడ పంపించేస్తాను. So v cancel అయిపోతుంది. v and minus v. I'll get 3v naught is equal to 4vx. So vx is equal to 3 into 60 by 4, which is how much? ఎంత? 45 centimeters per second. 3v naught by 4. Vx is 3v naught by 4. చూడడానికి డిఫికల్ట్ కదా, చాలా ప్రాబ్లం. ఇట్స్ వెరీ డిఫికల్ట్ నా, చూడడానికి డిఫికల్ట్. బట్ ఇఫ్ ఐ బ్రేక్ డౌన్ ఇంటూ నెంబర్ ఆఫ్ పులీస్ అండ్ నెంబర్ ఆఫ్ ఈక్వేషన్స్, it becomes very easy. All I did was I've written those two pulley equations for two pulleys, this pulley and this pulley. దీంట్లో ఎక్కడ కొంచెం క్రక్స్ ఆఫ్ ది ప్రాబ్లం వాజ్, ఇక్కడ v అనుకుంటే this has to be minus v. That's the only idea we should get. Rest all is simple.
Sir, is it 45 or 30, sir?
3 into 60 by 4. 15 4 60. 15 3 is 45. 45 centimeters per second. Okay.
VD 30, sir. B B.
B 30 వస్తుందా?
Velocity of B. Yes, sir.
30, all right. So this is 30 upwards, this is 30 downwards, అంతేనా?
Yes, sir.
All right, all right. If it only asks what is the velocity of this point on the string?
Same, sir.
ఎంత?
Same.
30.
30, right? Because all these points are connected with the same string. If this comes down, this has to go towards right. This has to go towards upward. Downward, rightward, upward with the same speed 30. All right.
Yes, sir.
All right. So let's look at another question now. మీరు అన్ని క్లాస్ వర్క్ చేసింది ఒకసారి నాకు చేసి పంపిస్తే ఐ సెండ్ ఎ డిపిపి. ఆల్ రైట్. If you do that DPP, that will be sufficient. You will not have any other problem more difficult than that problem in DPPs, the problems in the DPP. అన్ని మోడల్స్ కలెక్ట్ చేసి పంపిస్తాను. ప్రొవైడెడ్ యూ డూ ఆల్ ద ఎక్సర్సైజెస్ వన్స్ as homework in whatever done in class, do it as homework with all the possible methods. ఇప్పుడు వరకు 2 methods కవర్ అయ్యాయి. ఆ 2 methods మల్టిపుల్ మెథడ్స్ కవర్ చేసేయండి. You should get the same answers with both the methods. All right, now let's look at this one. I've got a block like this. Right? Now this is moving towards right with velocity v naught. Required to find velocity of this block Vx. ఎలా చేస్తాము? One end of the string is fixed. And I can ask you multiple questions. What is the velocity of this point? What is the velocity of this point? What is the velocity of this point? ఇలాంటి questions వస్తాయి. But let us first find what is the velocity of the Vx. ఎలా చేస్తాను? I'll not go with pulley method first. I'll go with push-pull method because one end of the string is fixed. దీన్ని push చేస్తే by x తో, if I push it by x, my string is slackening by x, x and x,
3x.
3x. Right. Now to tighten this one, this has to go towards right by y, let's say. Tighten ఎంత tight so ఎంత లూజ్ అవుతుంది ఇది? 2y. Right? If it moves by 2y, string will tighten by 2y. Right? So slackening ఎంత అయింది? 3x. Tightening ఎంత అవుతుంది? 2y. 3x should be equal to 2y because string is remaining taut every time. చూడండి, if this is moving towards right by x, so string is slackened by 3x. ఇప్పుడు 3x string ఏమో ఇక్కడ టైట్ కావాలి. For that to happen, if this pulley moves by x or y or x prime రాస్తాను. X prime, string will tighten by 2x. You all agree with that?
Yes, sir.
That means tightening should be equal to slackening. Only then string will remain tight or taut always. So that means 3x should be equal to 2x prime. So 3v naught should be equal to 2v naught prime. V naught prime is equal to 3v naught by 2. I got velocity of the block 2. But I want velocity of this point A, velocity of this point B, velocity of this point C. How do I do? చూడండి, I'll go with pulley method now. Before that, let us get the same answer with pulley method. Pulley method ఎలా చేస్తాను? I'll not talk of slackening at all. Velocity of this point is 0. Velocity of this point is Vb. Velocity of this point is V naught. Right? Look at this. Velocity of this point is V naught. Velocity of this point is Vb. ఎందుకంటే Vb ఈ పాయింట్ ఉంది. It is not V naught. It is Vb, some Vb. And velocity of this point is 0 because it attached to the fixed wall, fixed hinge, fixed surface. I should write bigger. I'm sorry. So velocity of this point is Vb towards right, let's say. Velocity of the pulley is V naught towards right. I'll write pulley equation for this one. For this upper pulley. What will it be? V naught is equal to
VB
VB plus
minus
0 by 2. So point VB is going with velocity 2V naught. Alright. So the point B is going towards right with 2V naught. And this point is going towards right
Yes,
with V naught.
sir.
Why is it lower point going with V naught? Because it's attached to this block. ఇది ఫిక్స్డ్ వాల్ కి అటాచ్ అయితే జీరో అయిపోయింది. ఇది ఈ బ్లాక్ అటాచ్ అయితే V naught అయిపోతుంది. Velocity of this lower part of the string is V naught. So if I write for this pulley Vx 2V naught plus V naught by 2 is Vx. So Vx is equal to 3V naught by 2. That's what we got here also.
Yes, sir.
But if I can get VB from here, I cannot get VB from here. Push pull method తో నేను డైరెక్ట్ బ్లాక్స్ తెచ్చుకోగలుగుతాను. బట్ VB ఎలా తెచ్చుకుంటాను? ఇంకొక బ్లాక్ అజ్యూమ్ చేసుకోవాలి. దట్ ఆల్ విల్ టాక్ లేటర్. But I want you to do every method multiple times so that every method gets consolidated in your brain. ప్రతి ప్రాబ్లమ్ కి మల్టిపుల్ మెథడ్స్ చేయండి. వన్ మెథడ్ యుల్ క్రాక్ ఇన్ ఎగ్జామ్. దట్స్ డిఫరెంట్ థింగ్. ఎగ్జామ్ లో ఏదో ఒక మెథడ్ చూస్ చేసుకుంటాము. బట్ ప్రాక్టీస్ లో యూ షుడ్ బి ఏబుల్ టు డూ ఆల్ ద మెథడ్స్. So VB velocity ఎలా వచ్చింది నాకు? I've used this pulley equation for this pulley. This is 0, this is VB. VB plus 0 by 2 is V naught. I got VB. From VB I got Vx. Fine. All right.
Yes, sir.
Okay. Uh, uh, uh. Okay, now let's look at this one. I've got fixed wall. So what will happen now in this case? ఇప్పుడు ఏమవుతుంది? Let us say this is moving towards left with velocity V naught. I have to find the velocity of the block. Velocity అంటే both direction and magnitude, or component form లో I cap and J cap. Again, what will I do? I'll stand on this block. If this moves by x, string is slackening by x, x, and x. 3x.
3x.
This block has to come down by 3x.
Yes,
If this
sir.
comes down by 3x, that means V naught, 3V naught. So minus 3V naught is the vertical velocity. Minus 3V naught J cap. And what's the horizontal velocity? Minus V naught I cap. So that's my velocity of the block Vx.
So can you explain once again?
Yeah. If this moves towards left by x, string is slackened by 3x. X here, and x here. That slackened string has to be tightened by the motion of this block, which comes down by 3x. So if its horizontal velocity is V naught, its vertical velocity is 3V naught. So my vertical velocity is minus 3V naught J cap. If I take downward is negative, upward is positive, leftward is negative, rightward is positive, minus 3V naught J cap. But then what is its horizontal velocity? It's moving along with the block. Horizontally, it's moving along with the block. So it's minus V naught I cap. So net velocity would be minus V naught I cap minus 3V naught J cap. Is it
Yes,
okay?
sir.
All right. Now let's go for a little complicated problem. Oh, there is one question. I'll send it to you better. He says, It's a good question. Read the question carefully. మంచి questions ని వదిలేయకూడదు, because it's very difficult to find good questions. మంచి క్వశ్చన్ ని మొత్తం ఎక్స్ప్లోర్ చేసి వదిలేయాలి. You explore it totally, tear it apart, understand everything, and then leave it. And in fact, you preserve it. మంచిగా నోట్స్ రాసుకోవాలి, బికాస్ రివిజన్ టైం అప్పుడు ఇట్ విల్ బి వెరీ హెక్టిక్. ఆ ప్రాబ్లం చెప్తారు, ఈ ప్రాబ్లం చెప్తారు, ఆ నోట్ బుక్ చెప్తారు, ఈ బుక్ చెప్తారు. ఈ 1 or 2 months మ్యాటర్ కాదు కదా, ఇట్స్ మ్యాటర్ ఆఫ్ 2 years. 2026 వరకు యూ హ్యావ్ టు కీప్ ఆన్ వర్కింగ్. Okay, so look at this. As I told you, he's asking multiple things in this one. But let's analyze bit by bit. ఏమేమి ఇచ్చారు? Block B, A and B. It's on the same horizontal level. All right. He's asking velocity of point C also. What else is asking? Block acceleration of block B is 3 towards right. VA, VB, VC. ఇవన్నీ కనుక్కుంటే రిలేటివ్ కనుక్కోవచ్చు. If I find the absolute velocities, I can find the relative velocities. How will you find relative velocity of A with respect to B? VA minus VB. Of B with respect to A, VB minus VA.
Students, please wait. I think there is power cut.
Yes, ma'am. Hello? Hello, ma'am.
Yes, sir.
Yeah, what? Students able to hear me?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. All right. There'll be a slight bright spot here. Ignore it. I'll be working here itself on this area, in this region. All right. So what VC? If I find VA, VB, and VC, I'll find relative velocities also. So let's use push-pull method. V not ఏది ఇచ్చారు velocity? Velocity of VB ఇచ్చారు. V not అనుకుంటాను. ఇచ్చేది V not అనుకుంటాను. ఇవ్వలేదు, ఇది VX అనుకుంటాను. And let this velocity be V. All right. Now look at this. If I push this by X, string stack length by X, X, X and X, 4X. And if this moves by X prime, string will tighten by 3X prime. Right? So 4X should be equal to 3X prime. So X prime should be equal to 4X by 3. So V naught prime or V naught prime, V naught is equal to 4Vx by 3. Vx is equal to 3V naught by 4. So V naught ఎంత ఇచ్చారు మనకి? 2. So this will be 3 by 2.
So can you repeat once again?
See, this all is calculation. Here is the physics. అక్కడ ఎండ్ అయిపోతుంది. అక్కడ నుంచి క్యాల్కులేషన్ చేస్తున్నాను, ఏం చేయట్లేదు. హౌ ఐ గాట్ దిస్ ఇస్ ద ప్రాబ్లమ్. దట్స్ ది సొల్యూషన్. ఎలా వచ్చింది ఇది? ఇఫ్ దిస్ మూవ్స్ బై ఎక్స్, string slackens by x and x, 4x.
4x. Yes,
Now
sir.
this movement should tighten this string. Tighten 4x slacken ఎంత అయింది? 4x అయింది. ఇది x ప్రైమ్ తో మూవ్ అయితే టైటన్ ఎంత అవుతుంది? 3x ప్రైమ్ టైటన్ అవుతుంది. ఇది x ప్రైమ్ తో మూవ్ అయితే టువర్డ్స్ లెఫ్ట్ ఆర్ రైట్, టువర్డ్స్ రైట్ మూవ్ అయితే x ప్రైమ్ తో ఎంత మూవ్ అయితే ఎంత టైటన్ అవుతుంది? x ప్రైమ్ అండ్ x ప్రైమ్, రైట్? సరేనా?
Yes, sir.
So this 4x should be equal to 3x prime,
Yes,
because
sir.
how much ever is slackened, same thing should be tightened. So string remains taut every time throughout the motion. So 4v x is equal to 3v naught. Vx is equal to 3v naught by 4. V naught is given as 2. So Vx is equal to 3 by 2. So ఇది 3 by 2 తో వెళ్తుంది, అది 2 తో వెళ్తే ఇది 3 by 2 తో వెళ్తుంది. So what is the relative velocity now? అది 2, ఇది 1.5. Velocity of B with respect to A is 0.5 towards right. నేను వెలాసిటీ చేస్తున్నాను, మీరు యాక్సలరేషన్ చేయండి. ఆల్రైట్, ఆల్ యూ హావ్ టు డూ ఇస్ సబ్స్టిట్యూట్ A naught హియర్. ఇన్స్టెడ్ ఆఫ్ V naught ఐ విల్ సబ్స్టిట్యూట్ A naught. నాకు యాక్సలరేషన్స్ వచ్చేస్తాయి. బట్ నౌ absolute velocity of the point C of the cable, that's what he's asking. That's a good question. చూడండి, velocity of this point is 0. Velocity of this point will be, ఇది Vx అనుకుంటే ఇది 2Vx. Velocity of this point will be V naught. Velocity of this point will be V naught. ఇది 2Vx, ఇది V naught, ఇది Vc. నేను ఈ పులి యూస్ చేస్తాను. ఇక్కడ రావచ్చా? ఇది 2Vx, ఇది Vc, ఇది V naught. సో V naught is equal to 2Vx plus Vc by 2. సో Vc ఎలా వస్తుంది ఇప్పుడు? 2V naught minus 2Vx implies Vc is equal to 2 into V naught minus Vx, which is 2 into 0.5, which is 1 meter per second. ఈ క్యాల్కులేషన్ వదిలేయండి, దట్ యుల్ అండర్స్టాండ్ ఎనీవే. బట్ ద పాయింట్ ఇస్ ఐఎమ్ అప్లైయింగ్ ద పులి ఈక్వేషన్ ఫర్ దిస్ పులి. నేను ప్రతి పాయింట్ కి రాసుకున్నాను వెలాసిటీ. ఈ వెలాసిటీ 0 ఉంటుంది because it attached to the string. This velocity will be V naught attached to this point. This velocity will be Vc, required velocity. This velocity is 2Vx. Why? This plus this by 2 is this one. So this will be 2Vx. V prime plus 0 by 2 is Vx. So V prime is 2Vx. 2Vx వచ్చేసింది ఇది. ఇది 2Vx అంటే ఇది V naught. ఇది Vx, 2Vx, V naught, ఇది Vc. ఫుల్ ఈక్వేషన్ దీనికి రాస్తాను. V naught is equal to 2Vx plus Vc by 2. V naught is equal to 2Vx plus Vc by 2 రాస్తాను. From there I'll get Vc. Fine. I can use this pulley also to get Vc. I should get the same Vc, right? Let's see, do we get the same Vc or not? I'll get Vx is equal to V naught plus Vc by 2. So Vc is equal to 2Vx minus V naught, which is equal to 2Vx ఎంత? 3 minus V naught ఎంత? 2, which is 1. I'm getting the same one value here. 1 ఇక్కడ వచ్చింది, 1 ఇక్కడ వచ్చింది. Whether I use this pulley or that pulley, I'm getting the same value.
Sir, it is not clear. Yes, sir, now it is clear.
Okay. Sometimes there is a glitches, right? And there is a glitch sometimes. Is it clear? Is the point clear? All I applied was pulley equation for different pulleys. This pulley and this pulley. I can apply for this pulley or for this pulley. But I've done both and checked whether I'm getting the same answer for VC or not. I got the same answer for VC. But to get the velocity of the point of C, I needed velocity of this point and this point as well. ఈ పాయింట్ వెలాసిటీ ఎలా వచ్చింది నాకు ఓవరాల్గా చేసేసాను. ఎలా చేశాను? v ప్రైమ్ ప్లస్ 0 is equal to vx. v prime plus 0 is equal to vx. So v prime is equal to 2vx. 2vx రాసేసాను. So 2vx plus vc by 2 is equal to v0. All right. Students, if it's clear, we'll stop here.
Yes, sir.
Yes.
All right. Students, again, I request you, by evening, you please practice these questions again. Just do it again with both the methods. Analyze చేయండి. ఇది left కి move అవుతే ఏమవుతుంది, right కి move అవుతే ఏమవుతుంది, all those you analyze and do it. It will not take more than 10 to 15 minutes. All right. So do that. You can do this in the lunch break or ఇప్పుడు కూడా చేయొచ్చు మీరు. Maybe you have to go to college now, but lunch break లో చేసుకోవచ్చు. All right. Please do that. And నేను కొన్ని ప్రాబ్లమ్ నంబర్స్ చెప్తాను ఈ బుక్ నుంచి ప్లీజ్ అటెంప్ట్ దోస్ ప్రాబ్లమ్స్. I'll tell you the problem numbers. 40, 41, 42, 44,
Sir, can you please do this
40,
side?
41, 42. Sorry? Yes? I'll mention the numbers here. 40, 41, 42, 44, 47, 50. 50 is a very good one. 52, 53, 54. That's it.
So can you tell me the page number?
Page number is 5.18. 5th chapter, 18th page. 5.18. Problems based on constraint relation.
Okay, sir.
40, 40, 47, 50, 52, 53, 54, and 54. That's it. Do these problems. All right, students. Thank you all. Have a great day. Bye, everyone.
Yes, sir. Thank you, sir. Yes, students.
Thank you, ma'am.
Students, again, we will meet in the evening. That is from 7 to 9. Right? Bye, everyone, and have a good day.